And to describe the issue, I'm going to use an example. I create a very simple table called cars. It has one column, car data, which is a binary XML. As soon as I create this very simple table, I can see in the dictionary that we have the car data column, the XML type, but it is in fact a virtual column. Underneath the hood, to support the implementation of binary XML, there's also a blob. It is the blob that contains the compressed and encoded version, the binary version of the XML document. You can go ahead and look in your own database in the dictionary to find columns that are storing XML in the binary format. Those columns might be affected by the issue that we talk about today. Imagine I have an XML document, some car data. It's a very simple XML document. In the real world, you could have much more complicated XML document. I want to insert this document into the database. When I do that, the first thing that the database must do is to compress and encode the XML document in the text format into the binary format that we can efficiently store and access in the database. In order to do that, the database will generate tokens from the XML namespace and the XML tags. Those tokens are stored inside the dictionary in a central table, and then the encoded binary version of the XML document is stored in the cars table. So if I insert this very simple XML document and I select from the table my car data column, including the hidden column created by the database, I can see that the textual representation is in the car data column, but the blob contains something that appears to be hex values. Let's take a deeper look at that hex value. In the dictionary, in the XDB schema, you will find a table called $QN. This is where the database will store the tokens that are generated from the tags in the XML document. We can see, for instance, the cars tag has been converted into a token. The ID is 50B4, and we can actually see that that token is used in the encoded version, the compressed binary version of the XML document. The same applies to the car tag and for all other tags and namespaces in the XML document. Knowing this, we can say in the table we have the encoded binary version of the XML. But in order to understand that, we also need the tokens from the dictionary. Both are required to read and understand the XML data. So when you move data with transportable tablespaces, we are moving the data files. What about the stuff in the dictionary, the tokens? Good news is that Datapump takes care of that when you do full transportable export-import. It'll move the tokens from the source database into the target database so we can read and understand the XML document there as well. But what happens during import if the tokens from the source database are already in use in the target database? We cannot just override the tokens in the target database because that would potentially corrupt the existing XML documents in the target database. And the other way around, if we don't import the tokens, we don't understand the XML document. To overcome this situation, if you have token conflicts during the transportable import, the easiest solution is to move that specific table with a conventional Datapump export. When Datapump loads the table into the new database during a regular Datapump import, it'll re-encode the XML document and generate new tokens. There will be no conflicts. But for a very large table, this might not be efficient. You might not be able to do that within your agreed maintenance window. In that situation, we have another solution where we can prune the tokens from the target database if it is a completely brand new empty database. We can then reuse the tokens from the source database and do some re-encoding in the target database before we do the transportable import.